So now we're going to learn about rationalizing the denominators. When we're dealing with radical numbers, there's two things that we always want to keep in mind. One is that the radicand, whichever number that we have as a radicand, that one never has a complicated radicand, right? So we want to make sure that it is expressed in the simplest form. And the second thing is that the denominator of a fraction is a rational number. Okay, what does that mean? That there are no radicals in the denominator. Okay, and the process to get rid of the radicals in the denominator is called rationalizing the denominator. So why don't we want a radical in the denominator? So here is an example of a number which has a radical in the denominator. We don't care if there's a radical in the numerator, we just don't want in the denominator. And let's try to add it with another number that has a radical in the denominator. The minute we see a scenario like this and we have to add these two fractions, it becomes really hard. Because remember, we have to try to find a lowest common denominator between these two denominators, which now it's root 2, root 7. So it would be nice to, if they were just whole numbers, like simple numbers like just a 2 or just a 7, then we can find their lowest common denominator. So we don't want to have the radicals in there. For the same reason also, we try not to have negatives in our denominator. We always make sure the negative goes to the numerator. Numerator being complex is okay, we can deal with it. Denominator not so. So the process of being able to get rid of the radical from the denominator is called rationalizing the denominator. And for this, we're going to use one of the ideas about fractions, which is called equivalent fractions, right? Okay. So remember when we learned about reducing fractions or raising them to a higher number. So if we have a fraction, let's say 3/5, and I, for some reason, want this 5 denominator to be a 10. So how can I make this into a 10? Well, you say, okay, times this by a 2. But if I multiply my denominator by a 2, I have to multiply my numerator by a 2 as well. So the rule of the fraction is if you multiply the numerator or denominator, either one of them, by a number, you have to multiply the other with the same. And why are we able to do this? Because 2 and 2 actually divide out to become a 1. Think about it, right? So in fact, we're actually multiplying 3/5 by 1, which doesn't change the value of this fraction, okay? So if I do multiply them by 2/2 or 3/3 or any number I want, yes, I manipulate this and it does look like a different fraction, but remember, the value of this fraction and the value of that fraction is in fact still the same. They're both 60%. Okay, so being able to do this manipulation lets us change certain aspects of the fraction. We're going to do the same thing for our numbers. We're going to be able to see if we can get rid of this somehow, this denominator. We can convert this root 2 to just a 2, and that way what can we multiply here, also here, that it will become 2. And that process is called rationalizing the denominator, and we're going to work through that in example number 4 and in example number 5.